And we are live. Thanks for tuning in, folks. No screwing around today, as we've got a lot to get to, as we typically do. So we're looking at sunspot 2738 as the trailing sunspot group continues to degrade. Let's look at the coloring magnetogram. Not the coloring magnetogram, the colored magnetogram. As that will give you a little better idea of the magnetic fields associated with the sunspot. And there we'll give you a big zoom in so you can see what's going on with the magnetism. If you weren't aware, folks, electromagnetism makes the universe go round. Gravity does not. I know it sounds radical. And let's give you one more view here. How about the 304 angstroms? We'll zoom it out so you can see any filaments. And please note that this is just today's activity. We're looking at about 8.5 hours there. So there's what's going on, and solar activity is pretty low right now. And let's move on. Here's the Earth scale. Here's the sun at helioviewer.org. And this is the 193 SDO view. I would note there is a coronal hole right there. And let's take a look at the real-time solar wind. And while that loads, I'm actually going to bring up the chat. So here's the real-time solar wind. We see a recent shift in the BT/BZ there, as we are now back in positive BZ territory. And that is a reference to the polar Z field's influence on the B field, which is the interplanetary magnetic field for all you new viewers out there. Phi angle is currently at 297 degrees. We see a recent addition of the 400 level on this for some reason, even though it's degrees, which end at 360. So we see an increase in the solar wind density here, up to 9.60 protons per cubic centimeter, and a 351 kilometer per second solar wind speed. Here's the latest images of the gong too. There's the last image. And we see a lot of magnetic complexity associated with that sunspot. Let's let it play through. Just keep in mind this data is approximately 2 hours old. And next we'll look at spaceweather.com. It looks like they're doing some Schumann resonances there. Let's see what's going on. And we've got radio bursts. By the way, we did receive a bunch of 245 megahertz radio bursts this morning. One of them was very strong, possibly a pre-indicator of a solar flare. So we'll be keeping an eye on that today. And it looks like the 10.7 centimeter radio flux has dropped down to 75. Still above forecast, but it might be 77. So it's dropped down a little bit, folks. Those of you not aware, 10.7 centimeter radio flux is a good proxy for a sunspot number. And I'm getting some volume fluctuations here that I can't explain. I don't know what's going on with the audio. All right. I think that's about right. And let's break out the chat here. And while that loads, I'll look at some more stuff. Let's head to spaceweathernews.com. Compliments of Ben Davidson. And let's get to the top of the page here. Maybe I should shut off the autoplay feature. All right. So we see a few B-class X-ray flares. That doesn't really count as very much. We see some spikes in the magnetometer here. Also, Geez. Not exactly fast loading these days, folks. All right, we see a major dip in the electron flux, indicating the probability of a coronal hole wind stream hitting, and that would explain the increase in the solar wind density. We should be looking for an uptick in the speed today. Charging hazards are minimal, as we typically see few with such low electron flux levels. The F2 layer is very discharged right now, and we look at it daily, so you don't have to. Head to theplanetstoday.com to show you your location. Milky Way galaxy team for the win, folks. It's tax day, the day that people think the government's going to cut them a check, when you've been cutting the government a check all year, and they're just giving you back some of your own money. Let's advance it 1 week. And there's where planets will be in 1 week. Next, we'll look at solar ham and their sunspot breakdown. So we're still looking at a beta class sunspot according to this. Don't be surprised if this gets downgraded to alpha class today. Next, we'll look at magnetosphere movies, but before we do that, I'm going to bring out the chat. Whoopsies. There we go. And welcome, viewers. Thanks for tuning in. We really appreciate it. This channel is growing, and even though we had a little copyright issue yesterday, we're going to get that all squared away, as it was fair use. Here are the magnetosphere movies, and we're going to probably see some spikes in this, so we'll look at all three today. Keep in mind, folks, you cannot request this data yet, and we thank the University of Michigan Geospace Department, if you will. Probably just the geology department. Anyway, here's the velocity. Let me shrink that down and blow that up. There we go. So there's the velocity movie. About what you'd expect. We see some turbulence around the magnetotail. Here's the density. We see a little denser environment there with that higher density solar wind. Go one size smaller here. There we go. All right, and here's the pressure. This is probably the most important one, folks. Some days we only view this one if there's not too much going on. And we do see some small perturbations there in the bow shock, about what you'd expect to see with the recent upticks in the solar wind density. We like when the data corroborates, and that's part of the reason why we crunch it every day. Next, we'll look at geospace ground perturbations. First at the poles, and then across the globe. Now, this is changes in the B field, Earth's B field, that is, which is why it says geospace delta B. Changes in the B field, folks. So there's a situation at the pole. I would note that the South Pole is migrating toward Western Australia, and that we have two North Poles, and that there's a massive polar excursion going on right now. Here's the magnetic perturbations over the globe. And I'm not going to break out the epic pen at all today, folks, because I'm trying to shorten this video a little bit. But we're crunching the data on a daily. Next, we've got cosmic rays. We're going to cover this today. We don't do it every single day, but here's Athens. Here's Mexico City. Here's Moscow. If I'm not leaving it on the screen long enough, folks, just pause the video. Here's Oulu, which is in Finland. There's DOMC Antarctica, only returning daily data now, and DOMB Antarctica, also on the same schedule, as winter is approaching in Antarctica. Next, we'll look at the Space Weather Enthusiast dashboard, and we'll look at the visible light image, just to give you another view of that sunspot and the trailing umbra. There's quite a lot of magnetic complexity following that sunspot, and not quite so much leading the sunspot. And let's move on to some more things. Like the total electron content. This will show you GPS errors, and that's why we show the whole world view, as we have viewers from all around the world. Dakota Horn. I have never seen the solar winds reversing going toward the sun. And good morning, Gregory, Dakota, and Mary. And smAsho staff. Thanks for your hard work, smAsho staff. And next we'll look at 24 hours of earthquakes. We're just going to read them off real quick, folks. Seismology isn't really my forte, but this channel does a lot of things. So we see a 4.4 at a 228-kilometer depth in Argentina. There's a 4.0 in China. 4.4 in Chile, also at depth. We're only going to report 4+ magnitude quakes, folks. Here's a 5.3 in the Bering Sea. What say you, tsunami.gov? No warning, watch advisory or threat. And for that, we thank you. It redirected me. That was nice. I thought it opened a new window. So anyway, that one located near Kiska volcano. Here's a 5.0 in Mexico at 100 kilometers depth, portending the possibility of deeper quakes at the surface. Here's a 4.6 in Indonesia and a 4.5 at the South Sandwich Islands, very far south. Here's a 4.6 in China. Here's a 5.0 in Japan, a 4.5 in Russia. Here's a 4.5 in Fiji at 573 kilometers depth, suggesting the possibility of a high-level 5 quake at the surface in the future. Here's a 4.0 in Nepal, 5.1 in the Philippines, a 4.7 in Burma, 4.5 in Peru, and a 4.9 in the Mid-Atlantic Ridge. Let's look at windy.com to look at the pressure maps and see if there are any anomalous lows that jump out at us. So, first of all, here's a low right over Kiska volcano, where that 5.3 occurred. If you don't believe in Ben Davidson's earthquake predicting technique, I suggest you head to quakewatch.net and read up on it. Everybody should be able to forecast earthquake, folks. And with these data sets, you can. We're still having audio problems here. I don't know what's going on. I'm going to turn that down and just ignore it. All right, so let's look for some more lows here. This is a pretty anomalous low right here, right near Fiji. Very powerful low there in the southern Pacific. Remember, folks, low pressure systems rotate clockwise in the southern hemisphere. Anyway, there's your windy.com segment. Windy.com, a great mobile app also. Highly suggest that you install it. Next, we'll just give you a quick image here of the U.S. Doppler radar, compliments of AccuWeather.com. We just had some strong storms move over, and I actually had a tornado watch right above my head. Fortunately, it was just a little quick severe thunderstorm, and the main part of it didn't really hit me. So there's that line of storms finally moving off to the east, and it is headed largely north. So if you're in any of those locations, expect these storms to train on top of you. You could get an extended period of extreme rain, thunder, and lightning. This line of storms has generated deadly tornadoes already. So be prepared, folks, if you're in New England, places like that. And if you're on a boat around these areas, I would batten down the hatches. Let's show you the water vapor map here, just to show you what's going on in the upper atmosphere as a value-added service. So there's that water vapor map. That should give you some idea of what's going on. For you new viewers, keep in mind the dry air masses are more massive than the moist air masses. And all things considered, dry air tends to override moist air. Another interesting feature is that dry air is associated with positive charge and wet air is associated with negative charge. And let's just leave it at that. Volcanoes today. What was it like on tax day volcano-wise? Well, Shivaluch was producing a 13,000-foot plume. Mount Ibu producing an 8,000-foot plume. Bromo with a 10,000-foot plume. Tucono, don't try to pole vault that 8,000-foot volcanic ash plume. Popocatépetl, 22,000-foot plume. Revenador, still producing a 15,000-foot plume. And Sabancaya looks like it's the star of the day with a 24,000-foot ash plume. Don't fly your plane, your drone, or your ultralight John Denver style aircraft over it. Next, we're going to look at Stereo A space weather beacon, as we do every day. This segment became popular during the last major coronal mass ejection, which wasn't really that major, but it mainly didn't hit the Earth. That was the main thing it did. And we reported on this before anybody else did. I got an alert because of the C flare, and within 2 hours of that, I was live streaming. Anyway, there's the coronagraph from Stereo A. And for you new viewers who are not aware, Stereo A is a satellite located 1/3 of the way around the sun, so we can see it from a different perspective. So for your new viewers out there, Stereo A is located right here. Sorry about that. It's located right here, very close to that area, and Stereo B is located around this area. So that view is like this, and it gives us a good indication when a coronal mass ejection is coming out the interplanetary magnetic field toward the Earth. That's all. And we don't see anything like that, but we do see a large plume of coronal plasma held in by magnetic fields. I would recommend you read andrewcollins.com article about Cygnus X3. This is a massive X-ray binary known as Deneb, also the celestial North Pole at the other end of the precessional cycle. And if you're in the Northern Hemisphere, you've had a very personal relationship with this thing as it has projected particles right through your head. Here are the transients from Cygnus X3, and it's been doing some odd things lately. Let me zoom in on that. See that? That is a very, very anomalous reading. See that? I've never seen it do that before. And if anybody has, we welcome you to leave a comment. Here's another article about active galactic nucleus Taurus. We call these massive radio sources, not black holes, since we endeavor to understand the physics. Now, the famous black hole photo is taken from this angle. While we're not right on the Z field, which is that line I just drew there, that's along the Z field, that's what we call the galactic jets. The black hole image that everybody's so excited about is about at this sort of an angle, next to the Z field. And then we're getting this picture of this that looks like a donut. Why does it look like a donut? Because the Z field is obscuring part of the image in the middle. There seems to be a fundamental misunderstanding of how these things work, folks, and we're striving to change it. We'll leave links to the article in the description. If you're interested in following these transients, as I am, head to this page. The Neil Garrels Swift Observatory Swift/BAT Burst Alert Telescope is what that stands for. Hard X-ray Transient Monitor. This monitors hundreds and hundreds and hundreds of radio sources from inside the galaxy and out. So let's just show you one. The famous alleged black hole, famously bet on by Carl Sagan and Stephen Hawking. Cygnus X1. Now there's a lot of X1s because that's what they name mysterious objects. Let's get down to Cygnus. Now this is located within our galaxy. And this is the first object believed widely in the world of astronomy to be a black hole. And there are the transients from it. We see some very low-level transients, very similar to Cygnus X3, even though it's a completely different object. Are they connected? Well, if we're measuring radio signals from it, they're connected to you, which means they're connected to each other too, folks. And let's move on to see what I was searching for. What I was searching for was M87, because I want to show you a zoom in. So we're going to attempt to get a zoom in here, and we're not going to run it full screen so that we can actually not deal with any copyright claims. I'm going to shrink it down. I'm going to shrink it down because I want to show you the galactic jet, since I don't understand how they can't see it. All right, so now I think it's painfully obvious that this is the jet that is coming out of the Z field right here, kind of like an expanding tornado, a giant Birkeland current coming out of the galactic core of M87. Now, as the zoom in occurs, you'll be able to clearly see that this Z field emanates from the galactic core. Here comes the zoom. There's the jet, which is painfully obvious. There's the jet. Please zoom. There it is, right at the core. And when the guy in 60 symbols gets to this image, he's looking at this image and he's saying, now this is obviously not that active, because if this was active, we'd see jets coming out like this. Well, the jet is coming out like this, folks. That's the orientation of the jet from this image. That's why it looks dark in the middle. Not because there's an event horizon. These things are massive radio sources of condensed matter, and they form on ionization pathways, the same way you, the planet, and the sun form. If you're interested in sponsoring a cyclist, sponsor me. I'm raising $5,500 by May 1st to get back into the road racing scene in the cycling mecca of Trexlertown area. That's Lehigh Valley, Eastern Pennsylvania. And I see we've got some donations now. So thanks everybody for donating. We've also started a nonprofit organization. So visit all the links in our description if you'd like to donate, as we are on a dental floss budget. And we need your help to continue the videos, to stay sustainable. And we are planning on putting some of the content behind a paywall. However, the most important content will always remain public and free. So please donate if you're able. You don't know how much of a difference it makes, donors. So we thank you. Let's read the charter of the nonprofit organization, as I guess this should be a normal segment on the channel. smAsho mission is 1. To assist, study, and report on the ongoing formation of a unified theory of physics. 2. To raise the awareness of the general public of the relationship between space weather and Earth effects. 3. To connect and consult with media organizations to multiply our reach. If you are able to help us do that in any way, viewers, please email me at smashomash@gmail.com, and I will make that happen if I'm able. I have been on the local radio station, and I call national radio shows almost every day. 4. To demonstrate cutting-edge proof-of-concept solutions to problems. 5. To publish scientific papers, and we're looking at 3 of them this year, in a multidisciplinary manner, including sciences such as, but not limited to, spectroscopy, chemistry, astrophysics, health, wellness, longevity, cosmology, biology, magnetohydrodynamics, geology, etc. 6. To assist mankind by advancing the study of predictive phenomenon in order to optimize value, reduce risk and liability, save lives and resources, and adapt no matter what the adversity is. And lastly, and possibly the most important of all, to not be ossified in our beliefs and to treat those who are with love, respect, and inclusion to the scientific discussion. Speaking of scientific discussions, if you want to hear some stuff that'll scare the pants off of you, watch this video on the Watchers, Doug Vogt's latest, which I believe just came out yesterday, entitled Where to Go and How to Survive the Next Pole Shift and Ice Age. Do I believe everything Doug Vogt says? Absolutely not. Should you watch the video anyway? Absolutely you should. Why? Because Doug Vogt's theories are some of the only theories in existence which explain Earth's geological catastrophe cycle. If you've studied geology at beyond the 5th grade level, you would know that there is some sort of a cyclical catastrophe cycle on our planet, and you may be well informed and wise to learn about it. As science is advancing at a breakneck speed, if you stop paying attention, it could be more than detrimental to your health, let's just say. We'll leave links. Next, let's look at the zoom in to Andromeda, another Messier galaxy. Yes, that's right, your closest major galactic neighbor, the Andromeda galaxy. You want to see something weird? Well, I'm going to show you something weird today. And we're not going to make it full screen because, I mean, hey, don't algorithmically copyright strike me, folks. We got a copyright strike yesterday because we were showing a 60 symbols video where the guy was talking about jets coming out of M87 radially when you're zooming in right along the jet. So I don't understand that. I mean, the guy's an astronomy professor, and we really wish that we would get to a unified theory of physics. It's part of the reason why I left college and went into pro sports. So let's look at a zoom in of the Andromeda galaxy. There's the Andromeda galaxy. You want to see what's going on in the middle of that? Now, this is based on measurements, folks. Nobody's claiming to have an image of a black hole here. However, wait a minute. This is one of the weirdest places in space. And it's not working. I'm gonna show you the zoom in regardless, folks. I know I have it. I think it's public domain, but let's see here. Maybe it's this one. I know it was a Hubble image. I apologize for the delay. Please bear with me. When you see what's going on in the core of Andromeda, you might be a little surprised, as things can be weirder than you may expect. Now, these are mainly blue giant stars, blue supergiant stars for that matter. And that wasn't the right video either. All right, let's try one more time here. because it is an animation, and it is based on radio telescope interferography. Maybe this is the one. I don't know. I've seen it years ago. I guess that's as far as they zoom. Anyway, there's a bunch of stars going around the galactic core in a very short period of time. We got to move on because we got to get out of here. Now, here's a view of the sun from the North Pole. Now, we've never had a spacecraft fly over the North Pole, but one of them, Proba 2, got near it and stripped these images together, stitched these images together. Now, what's the relevance of this? Well, the relevance is that the center of this image is looking down the sun's Z field. So if you could see it, it would be like this. And it's causing this field to be, it's causing this image to be distorted because you're looking down a really, really powerful magnetic jet current, a Birkeland current with massive amounts of electrical current flowing right toward you. Also, there's a coronal hole in the poles of the sun, mostly all the time. And that's an image of what it looks like. We'll leave links to this also, because people are not aware, and we're trying to make them aware. So we also got an Instagram page, and I wanted to read a quote. This is actually from one of our comments. I want to read part of this quote. I screenshotted it on purpose because the day I stop calling, the day that I stop calling them like I see them is the day that I'll be fired, and that means I'll quit. You won't catch me lying because I never do it. The reason I handle criticism so well is because of my namesake. My ancient Hebrew name means literally, my judge is God. What that translates to is that I answer to a higher power than any human critics. This is why people pay me to do science. My agenda is the truth. I don't ask for responsibility or go to the front of the line. People request that I take responsibility and report to the front of the line. And that's why this channel exists. If you're interested in cycling, head to theveloshop.net and buy a bike or something. I mean, how about a track bike? How about that? Break out a nice new felt track bike. How about the TK3? Carbon fiber beauty. You want to teleport down the track? Try that out. Or if you want to go real crazy, how about the Fuji Elite Pro? Complete with an oval wheel set. That's a real carbon wheel set, folks. And let's go back to the sun and show you the 171 angstroms view as it's nice and bright and cheery and happy. It'll show you a great image of the sunspot 2738 in all its magnetic complexity. This image is great at showing magnetic looping. And there you have it. Now let's break out the chat before we break out of here. It's going to be a jailbreak, folks. What up, snowflake vaccine? All right, if you got any questions, comments, etc., now's the time to do it because we're about 30 seconds from closing this thing down. All right, everybody. Thanks for tuning in. Please don't forget to like and subscribe if you haven't done so already. Please share on your social media, as we can't even seem to get to 1,400 subscribers for some reason. Maybe people don't like the comment. The content. We definitely like the comments, so keep those going. And best wishes on your tax day. Hope you get a lot of money. Hope you get a lot of your own money back from the government there, folks. So in any case, when you're staring at the sun, don't drink, and if you drink, don't drive. And may the solar wind be at your back and the atherosclerosis absent from your veins.